Chapter 9.3, Day 1, we're looking at trigonometric functions of any angle. So you can generalize the right triangle definitions of trigonometric functions so that they apply to any angle in standard position. So general definitions of trigonometric functions. Let theta be an angle in standard position, and let xy be the point where the terminal side of theta intersects the circle x squared plus y squared equals r squared. Now looking at that x squared plus y squared equals r squared, what does that remind you of? Hope that reminds you of the Pythagorean Theorem, where a is one side, b is the other side of the leg, and r squared will represent the hypotenuse. So notice this here. The 6 trigonometric functions of theta are defined as follows. So let's just say for a moment that we'll say theta is here. So sine, if we remember sine is always opposite over the hypotenuse. So let's just say this is the angle here. Okay, so I'm just going to change it. Opposite pertains to what? Opposite is going to be this here, this height here. And this height, that should remind you that that is our y value. Okay, so just this is the y value. How far is it going up? Then this value down here is going to be our x, right? So let's just look at that. So if this is, for example, -2, we go left -2, so that's the length of x. And then say this is up 1, then that y value is 1, right? So -2, 1, left 2, which is that length, up 1. So sine of theta, therefore, is, looking at just the values that we labeled it here, opposite here is y over the hypotenuse, and the hypotenuse is really the radius here, r. So therefore, sine of theta is y over r. Then cosine of theta, remember that's adjacent over hypotenuse, adjacent over the hypotenuse. And so adjacent in this case is the x. X over r. Then tangent of theta, tangent is opposite over adjacent, and so opposite is the y over the adjacent x. So this is y over the adjacent x. And then of course x cannot equal 0. So let's just write that down here, that x cannot be 0. Now let's look at cosecant of theta. Cosecant of theta is just the reciprocal of sine. So therefore we can say that it's the radius over y. Secant is the radius over x. And then for cotangent, it's x over y. So these functions are sometimes called circular functions. We won't really ever refer to it that way, but in a future textbook you may see that. So the big thing to take away is that sine of theta, I know we know that from previously as opposite over hypotenuse. Think about that now as y over r, because we're looking at a right triangle here inside of this circle. So y, which is the opposite over the hypotenuse r. Cosine is still adjacent over hypotenuse, so adjacent is now our x value over r. Tangent is opposite our y value over the adjacent x, and then the reciprocals on this side. So given this information, let's evaluate trigonometric functions given a point. Let -4, 3 be a point on the terminal side of an angle theta in standard position. We're going to evaluate the 6 trigonometric functions of theta. Now when it asks for that, we want to know sine, cosine, tangent, cosecant, secant, and cotangent of theta. So what you do is you plot the point. So we plot the point -4, x is -4, y is +3, and we plot that point. And then we label the sides of the triangle with our given. So y is 3, so we'll say y is 3 here. This is 3. And then our x value is -4, right? This is x. So this is negative 4. Now, the only thing we don't know is r. So remember, all the way at the top, that we have x squared plus y squared equals r squared. X squared plus y squared equals r squared. So in order to solve for r, we're going to use that, the Pythagorean Theorem. So let's do that. So let's say r squared equals x squared. So x is negative 4. So negative 4 squared plus our y of 3 squared. So r squared equals negative 4 squared is 16 plus 3 squared is 9. So r squared equals 16 plus 9, which is 25. Now we need to square root both sides. So therefore, radius equals 5. Notice that it's always positive because that is the distance. We don't need it to be negative, so it'll just be positive here. So r is 5. So here, remember that x is negative 4, y is 3, and r is 5. So let me just write that real quick. X equals negative 4, y equals 3, and r equals 5. Now, given that, we're going to use these ratios that we got from the beginning to write all of the answers down here. So sine, remember that that is y over r. So y is 3 over the radius 5. Then cosine is x over r. So x is negative 4 over the radius 5. Tangent is y over x. So therefore, that is 3 over negative 4. Then, because we know these answers, sine, cosine, and tangent, we just take the reciprocal for the ones at the bottom. So cosecant is a reciprocal of sine, therefore it's a positive 5 over 3. Secant is a positive 5 over negative 4. Cotangent now is a negative 4 over 3. So now, try out 3 more here. Now, for number 1, just as a hint, you are going to have a square root as part of your answer. You'll get a square root of something. You'll have to simplify it. And then you have to remember to rationalize the denominator when possible. Okay, so this one's going to be a little more challenging, but still doable. Then number 2 and 3, those will be perfect numbers when you take the square root, so that works out very nicely. So if you're having a little bit of trouble with that, or just have trouble with rationalizing the denominator, do number 2 and 3 first, and then try number 1. I'll show you the answer in just a minute. Okay, so if you tried this out, for number 1, the radius you should have found was 3 over square root of 2. Then, when you found sine of theta here, it's y over r. So therefore, I label x and y here to help me out. So y is a negative 3 over the radius of 3 square root of 2. You cancel out the 3, so you're left with negative 1 over root 2. But because I have a square root of 2, I'm going to rationalize by multiplying by root 2 over root 2. So notice the 3's canceled out. So what I'm left with is a negative square root of 2, and then square root of 2 times square root of 2 is square root of 4, which is a 2 here. For cosine theta, x over r, so there's a positive 3 over 3 root 2. It's very similar to sine of theta, but now it's positive because our x is positive. And then we get a positive root 2 over 2. Tangent is y over x, so therefore it's negative 3 over 3, which is negative 1. Then you take the reciprocal. So as a hint, I look at the first one that I wrote. If I know that there's a radical in the denominator here, I don't want to take this one because then I have to do a lot more work. So I just flip it. And so what I will get is square root of 2 over negative 1, or just square root of negative 2, or negative square root of 2. Then secant is the same except it's positive. And then cotangent, x over y, is still negative 1. For number 2, the radius is 17, and so hopefully you found those trig ratios pretty quickly. Make sure that you are looking at the signs. Signs are very important. And number 3, the radius here is 13. Homework is out of the textbook. It's page 482, number 3, 5, and 7, and this is what it looks like. So show the work on a separate piece of paper and then enter the answers on bigideasmath.com.